Good day, the grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Cybono Discovery Center. You can WhatsApp us at 079 578 2908. So today we're going to look, in our revision program, we're going to look at two topics in paper 2, which are the analytical geometry and the trigonometry. The marks for analytical geometry in our paper 2, it's 20 plus minus 25 marks. So we're going to look at how we can then approach the 25 marks and what type of questions are there in the 25 marks. The other topic that we're going to look at is the trigonometry, which gives us plus minus 50 marks. So we want to also check the number of the questions that we're going to have in trigonometry that can make us achieve up to 50 marks. So the two, it's almost analytical geometry and trigonometry, it's half, the marks there at half of that paper. So in other words, it's 75 marks, which makes half of paper 2. So we're going to look at that today. So now I'm going to start with the information sheet, which is very, very, very important. We're always talking about the information sheet to say these formulae are the ones that we use in technical mathematics. And the formula sheet is given at the end of the question paper. So you go to your last pages of your question paper. That's where you'll get 2 pages of the formula, the information sheet. So for analytical geometry, so it is very essential that you go to your formula sheet and write down what that formula is for. Before you go into the examination, you must know that, so that when you go into the examination and you group those formula, you group those formulae, and you know which one to use where. The first one is the distance formula that I have there, which is denoted by the letter D. So it's x2 minus x1. You don't need to go and memorize this formula because this formula are given to you. So don't memorize them. Just know which formula it's for what. The next one is the midpoint formula, denoted by the letter M, capital letter M. The next formula is the gradient formula, which is denoted by the small letter m, with y2 minus y1. So please check it in your formula sheet and make a correct choice there. So it's y2 minus y1, not plus. You can see the minus, because mostly we find in our final examination that most of the learners have written a plus sign, but they've got the formula sheet with them. So please let's make sure that we check that. The inclination, that is the gradient, equals to the tangent of an angle. The ellipse, that's the formula for the ellipse there, x2 over a squared, and x squared over b squared is equals to 1. Okay, right. So now let's look at the activities for the analytical geometry. The first activity there, this is a question, all these questions have taken them from the past papers, so you can see how they set in the papers. Now let's look at this. In the diagram below, ABC is a triangle. So you are told that ABC is a triangle. It's got the vertices A, given as -2 and 5. Make sure that what they say in the statement is also on the sketch. B, it's 8, and P. C, there are no values for those coordinates. You are also given that the inclination angle is 135 degrees. What do you know about the angle? And the angle, the tangent of the angle gives us the gradient. So that we must know also. Right. AC, it's parallel to the y-axis. So you're given that AC is parallel to the y-axis. And we're also given that BC is parallel to the x-axis. So meaning that this one is parallel to that. Already I know the gradient of AC, because I know that parallel lines They've got same gradient because I know the gradient of that line there. The gradient of that line here is also parallel to the to the x-axis. If I know the gradient of BC, I know the gradient of the y-axis. If I know the gradient of the y-axis, I know the gradient of BC. Now the first question says, determine the gradient of AB. So I go to AB, the gradient of AB. So I can see A has got a point there and B has got a point. My challenge now is that the point B has got a P and I need the gradient. So I cannot get the numerical value of the gradient if I've got a P there. So, but what else do I know? I know that I'm given an angle here, and that angle gives me, it's an inclination. So the inclination gives me the gradient. So what am I going to do? So I'm going to say the gradient is equals to the tangent of an angle. And what is that angle there? It's 135. So which means that the gradient of that, it's tan of 135. Remember the formula there. So the tan of 135 is going to be -1. Good. I can just use my calculator there to get the gradient of 135. So the gradient of 135 will be -1. So the gradient of AB is nothing else but -1. Okay, right. Already I know what the gradient of this line is. It's -1. So now they say show that P is -5. So you see that already the answer is given. So but I must work it out. So how do I work it out? I already know that the P is on my line AB. So I can use the gradient. So the gradient of the line, what will be the gradient of the line there? So the gradient of the line is going to be, the gradient of AB will be equals to y2, so it will be P minus 5, the y value minus the y value there, divided by 8 minus into -2. But I know that the gradient there is already there, so it will be -1 because the gradient of AB there, I already know it's -1. So then I can have P minus 5 all over 8 plus 2, which is going to be 10, equals to -1. I already know the answer, so I'm working towards the answer. Sorry, this is -1, sorry, -1. Right, so I'm going to have 10 times -1 will be P minus 5 equals to -10. Transpose the -5 that side, then the P will be equals to -10 plus 5 will give us a -5. So that is what I was requested to show, that P is -5. Okay, all right, that was not very difficult, it was straightforward. So we just need to know that if the gradient is given, I can get any other point, either x or either y. In this case, I needed the value of y, but it is indicated by the letter P. Okay. Now determine the coordinates of M. Now you're told that M is the midpoint of AB. So we know it's somewhere there or there or there somewhere. So it's somewhere there on this line. So I need to find the gradient of, the coordinates of M, which is the midpoint. So then I go to my formula sheet, I look for the formula for the midpoint. The formula for the midpoint is a capital letter A. But now already I know that my P there is -5. So I need to find the gradient, so the coordinates of M, which are the midpoints of AB. So AB, so I'm going to say -5 minus 5. I'm starting with the x values, remember? 8 plus -2. So it's 8 minus 2 all over 2. The other one will be -5 plus 5. So it's -5 plus 5 over 2. Remember, the midpoint is plus. It's x1 plus x2 divided by 2. y1 plus y2 divided by 2. So my midpoint there will be 8 minus 2, which is 6. 6 divided by 2 is 3. -5 plus 5 is 0. 0 divided by 2 is 0. So my M will be somewhere there, which is the point 3 and 0. And I know I am right because at that point is the x-intercept, which where the value of y will be 0. Now they say write down the equation of BC. So I'm looking at the BC there. BC passes there. The y value is -5. So and it's 1 mark. So the equation of the line BC is that point there. So I'm going to write down y will be equals to -5. There's nothing to work out there. Work it out. For 1 mark, it's still going to be the same because we're going to say y1, y minus y1 equals to the gradient. The gradient of that line there is going to be 0. So you're going to have that value of y to be equals to -5. Okay, right. Then E, write down the coordinates of C. So already I know that this is 5. Now I need the coordinates of C. So remember this point here is -2, and this is a -5. The y value is -5. So the value there is -5. So where the two lines meet will be the coordinates of C. So my coordinates of C is going to be nothing else but C will be, the x value will be -2, the y value will be -5. And those will be the coordinates of C. So the C point is -2 and 5. But now I can also use this point here. You can see that point there is -2. So the -2 will still remain as -2 there. Then the 5, because that one is positive. And I can see there's equal distance from here to there, and there must be equal distance from there to there. So that the one will be, instead of being positive, it's translated on the x-axis, so it becomes -5. So I can use that point to get to there. But remember, you must check the distance between this and the distance between this. So that will be 5 in this case, because I know at the bottom there it's -5. I already know that. Now, the next question says show that. So the question that says show that means that I must then prove something here. I must know my nodes there. I must know that if I've got perpendicular lines, what happens? If I know that two perpendicular lines, their gradients, when multiplied together, we get -1, then I'm already there. So if I know I've got two parallel lines, they've got the same gradients. Know those two things there. Now, if I want to show, so which means that I need to show that CM, so remember my M is there, so my M is 3 and 0. So I want to show that line here, CM, is going to be perpendicular to that. So I must show that that line is perpendicular to that. How do I show that that line is perpendicular to that? I must show by using the gradient of this line times the gradient of that line, and that should give me -1. So first I must get the gradient of AB. I know the gradient of AB. I already know the gradient of AB. So the gradient of AB times the gradient of CM must give me -1. So I already know the gradient of AB is -1, but I don't know what is the gradient of CM. I've not calculated it anyway. So I need to calculate it. So the gradient of CM will be a 0 minus -5, so it's +5. And we have a 3 minus -2, which is 3 plus 2. So if I can prove that this one times that one will give me -1, then here I'll have -1 times, I'll have a 5 over a 5 there. So now I can see that's -1 and that is a 1. So 1 times -1 will give me a -1. I can then say therefore CM is perpendicular to AB. Right. But what I can do is first I can prove that side first, and then from there I can just equate it to the right hand side, and then I'll have the 2 being equal. I can then say therefore CM is perpendicular to AB. Okay, right, so 2 lines that are perpendicular, the gradient, the product of the gradients is equals to -1. Then the last question on this activity, on this part, is on the same question here. You can see we have a lot of questions that are based on this. So whatever you got in 1.1, you can use it in in A, you can use it in A. Determine the equation of the straight line parallel to CM. So we need, here is our CM. So we need the equation of the straight line parallel to CM, but that line should pass through point A. So in other words, I need another line here. It must pass through point A, but this line must be parallel to that. So already you can see I have parallel lines. So if I've got parallel lines, so how am I going to get the equation? How am I going to get the equation of this? The equation of the straight line. So this equation of the straight line, I already know what is the gradient of CM. Remember, I got the gradient of CM, which was equals to 1. Right? So which means that the gradient of that line that is parallel is also equals to 1, because parallel lines have got the same gradient. So I've got a point. So which means I'm going to have y minus y1 equals to x, the gradient into x minus x1. Okay, so I'm going to have y minus, my y1 is going to be 5, my gradient is 1, my x1 is going to be negative, which is going to be plus 2. So my y will be equals to x plus 2 plus 5, and that gives me y equals to x plus 7. So I'll have that as my equation. So my equation is y equals to x plus 7. So how do I know, how do I check if I'm correct? The gradient there is positive. This value there will be the y-intercept, which is positive 7. So I'm there. Okay, I'm correct. But if I got any other value which is negative on this side, you can see if I got a negative y value, y c to be negative, so it must be somewhere there, and that line cannot go over to the side. Okay, so then I know I'm correct. Okay, right, now let's check activity number 2. So in this question, the first question will basically be your grade 11 questions. So the part 2, which is question 2, right there, it will be your grade 12 work that you have done in circles. So it will be circles. Right. Circles, the question says, determine the diagram below shows the circle of this. The equation of the circle is this. So already the equation of the circle is given. A is the point of contact of the tangent. You already know that this is a tangent. Write down the radius of the circle in simplified set form. Please, let's adhere to what has been asked. If they say, they say in a simplified set form, you must write it in simplified set. Because the radius here squared, it equals to 20. The radius will be the square root of 20. But this is not in a simplified form. So you can see if they say, if they can just say, write down the radius of the circle, we can leave our answer there. But once they say in a simplified form, then it means that they want us, simplified set form, they want us to write it as 2 root 5. And that's where you get your mark. Okay, so if you leave it at square root of 20, you have not answered the question that they gave. The question that they gave you, it's simplified set form. So let's read the question, understand the question, and write down the correct answer. Determine the equation of the tangent to the circle. So in other words, this is the tangent. We need the equation of this line, but we only have a point. We don't have the gradient. So what do we need to get? We need to get the gradient. So what do we know about this line? It's perpendicular. So you can see in this question paper, they asked a lot about perpendicular. This is the second time they're asking us about the perpendicular. So if you don't understand the perpendicular part in the first question, you will not be able to can answer this question again. So make sure that you understand it. Right. So now first we must get the gradient of the radius. So the gradient of the radius is 0 minus 2, which is 2, divided by 0 minus 4, which is negative 4. So minus 2 minus 4, the gradient will be negative 2 over negative 4, which is going to be a half. So if I know the gradient of this, I will know the gradient of the tangent. What will be the gradient of the tangent? We take this one, we swap it around, the numerator becomes the denominator. The denominator becomes the numerator, so that becomes negative 2. So I know the gradient of the tangent. So the gradient of this tangent now will be negative 2. I've got a point, so no problem. So I'll have what? Y minus y1 equals to m into x minus x1. Remember, I'm looking for the gradient of this line. So it's y minus, what is my y1 is 2. What is my y2 is going to be, gradient is negative 2. My x1 is going to be negative 4. So I'll have y equals to negative 2x plus 8 plus 2, and that will be negative 2 plus 10. That is the equation of the tangent. So if I look at that point here, it will go up, 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 up. This line will go up, 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 up there. So the 10 will be somewhere there. So I already know, okay, my y value will be 10. The gradient is negative. Then that line there has got a negative gradient. Then I'll have y equals negative 2x plus 10. Okay, I think we're doing very well in this. Okay, now, then I'll look at question 3, that question C there. It says write down the coordinates of the other point. See, we must read the question. Read the question and read it again so that we understand. They say write down the coordinates of the other point where line AO. So the line AO is this one. AO, it intersects the circle at this point and at that point. Can you see? So we need the coordinates of the other point. So where it connects with the circle. So it connects with the circle at that point. So we need the other point. Okay, so that's just the reflection. So in other words, the coordinates of the other point is going to be, so we just write the coordinates of the other point there. So if it's 4 this side is going to be negative 4. So we'll have a negative 4 for the x. For the 2 there we're going to have a negative 2. So we're having a negative 4 and a negative 2. So it's just a reflection on this. Okay. So it's just a reflection on this line. So that value appears again there, but with a negative. Okay, so that's minus 4. All right. Now this question comes every year and we still struggle with it. At least we must get these 3 marks. These 3 marks, every child must get this mark every year. This question is there. But in this case, sketch the graph. I took it and then I just changed it a bit, so that then you make sure that you read the question and then you understand what happens. So if I go to my formula sheet, I'll see that the formula is x squared over a squared plus y squared over b squared equals to 1. So I can first check this one. The square root of 16 here, it's x squared all over 4. plus y squared all over 16 equals to. So the easy way to get your x and the y intercepts is, if I say x squared equals to 4, x will be equals to plus or minus the square root of 4, which is 2. For my y values will be y squared equals to 16, y will be equals to plus minus the square root of 16, which is 4. That's the easy way of finding your x-intercepts and y-intercepts, because we see a lot of things that happens where you write down the values as they are on the Cartesian plane. So you must remember it's x squared, so you must take the square root of that number at the bottom. So now we check now. For the x we need minus 2, we need a 2. For the y we need a 4 and a negative 4. Then we use freehand to draw this. Please, it's freehand, okay? So how do we mark this? We have one mark for the y value, we have one mark for the x value, we have one mark for the shape. So it's 3 marks. Okay, right. So it is very, very important that we really know how to do this question. We must practice it and practice it and practice it until we get it right. Sometimes we find that this is there and this one is there, so your ellipse will be the other shape. Okay, right. So basically in unitary geometry, these are the 3 types of questions that we get. The first one will be the grade 11 type of work, and the second one will be the circles. Sometimes the circle is given as a semicircle, so please note that, and sometimes it's given as a full circle. So look at the 2 equations and know how to do them. The last question will be the ellipse. Right, we are going to trigonometry, but before we do trigonometry, we're going to take a short break. We are going to take a 1-minute break. Welcome back. Now let's go to the trigonometry. Now in trigonometry, we also have the formula that we're going to be using, which are the ones there. You see the formula for the sine rule. Please, we don't use the sine rule as this, we use 2 of them at a time. Okay. The cosine rule, please know your cosine rule. You have the area rule. You use the area rule when requested to do so. And this will work when we have a triangle without a right angle. Okay. So please make sure that you know that we have the identities. We've got the 3 identities that you must always know. And I'll request you to, in the exam, before you start with the trigonometry, you just write in your tangent of theta, it's equals to sine theta over cos theta. Just include it there in your formula sheet before you write. Okay. Now, the trigonometry, we have the right angle triangle. You all know that the ratios are also very important. These are the coefficients, the cofunctions for the ratios there. Sine and cosec, cos and sec, know how to change them, okay? You can see sine is y over r, cosec will be r over y. So if you know cos, then you must know your sec. You know your tangent, you must know your cot. So all this, the angle, if it's there, that side is the opposite, this side will be the adjacent. That side is always the hypotenuse, opposite 90 degrees. So if my angle is there, that side becomes the opposite, this side becomes the adjacent, the hypotenuse remains the hypotenuse. Okay. All right. Now the reduction formula. Remember, all six trig ratios there are positive. The sine and its cosec there is positive, the rest are negative. The tangent and the cot there are positive, the rest are negative. Cosine and secant they are positive, the rest are negative. So the reduction formula there, you see it's 180 minus, and we have 180 plus. Can you see 180 minus, it's in the second quadrant. 180 plus, it's in the third quadrant. We have 360 degrees minus, which is in the fourth quadrant. Okay. The pi there represent 180 degrees. When we have 2 pi, it means 360 degrees. So these are radians, okay? Pi is a radian, 2 pi is a radian, so we change that to degrees when we are working in trigonometry. Okay. So all the ratios will stay the same, so meaning that we don't change any ratios. Okay, please don't practice with the math learners, because those ones, they like changing them. Okay, they will confuse you. Let's look at the first question. Activity 1, Pythagoras type questions. In the diagram below, P is represented by that coordinate -8 and -15. How do I know that that part is correct? Because it's in the third quadrant. Okay. Coming without using a calculator, and mostly they write it in capital letters so that you see, or bold, so that you can see that no calculators are supposed to be used today. So the first question there, okay, sorry, just need to go back there. Right, the first question there says determine the length of OP. So the length of OP, O to P, first I like doing this and connecting. I'm always connecting to the x-axis. So I'll have a -8 as the value of x, 90 degrees. The value of y is -15. I don't have r. Remember, this is working in a unit circle. It's a circle. R, y, r, it is because it's the radius. Y, x this side because it's the x-axis. The y value is the y-axis. So the length of OP, I can use the theorem of Pythagoras there. So OP squared will be the same as, because it's the hypotenuse, it will be the same as -8 squared plus -15 squared, and that gives us 64 plus 225, and that will give me 289. So this is OP squared, remember. Therefore, my OP will be square root of this, which is 17. Please do not write down plus minus. Why? Because it's the radius, and the radius is the distance. The distance can never be negative, okay? So, the tangent of P, now I know what the length is, 17. The tangent, I know tangent is the angle is there, so the tangent is opposite over adjacent. So my tangent now will be -8 over that will be -15 over -8. So remember, the angle is there, the opposite is there, the adjacent is this one. So the answer there will be 15 over 8. Please leave your answer as fractions. Do not try to write them as decimals, okay? Just leave them as fractions as 15/8. Now the last one there is 1 minus. So once it says sine squared, then that thing there, remember pi is 180 plus x. But we know 180 plus x, it is in the third quadrant. In the third quadrant, the sign is negative. But because it's squared, then it changes the sign to be positive. So this thing will remain sine squared of x. And if I want to be smart, this changes to cos squared of x, because I know that sine squared of x plus cos squared of x gives me 1. Then if I transpose the sine squared of x on the other side, I'm left with cos squared. That gives me that. I go to my diagram, I need the cos squared of an angle. So this one is not x, it's supposed to be theta. So that's supposed to be theta, theta, so that's theta. So because we're working with the theta there. So now we have the theta. So the cos squared of theta, it's adjacent over hypotenuse, which gives me -8/17. And then remember this thing is squared, and that gives me 64/289. That's my final. Okay, so remember, we first work it out, and then from there we are able to then write down, because we have not used any calculator in this one. Question was very clear in terms of using a calculator, no calculator. But when you say no calculators, we're not saying you cannot punch in -8 squared or -15 squared. That you can do. How do we know that we have used a calculator? When we start to see the decimals. That's where we know the calculator here has been used. Okay, the second type of question you can get in that part of the question, the Pythagoras type question. Consider 12 tan A equals to 5. A is between 90 and 360. What does this mean? It means that I must first make tan A the subject of the formula. So I'll get the tan of A, it's equals to 5/12. See? Once I've done that, now I can be able to draw my sketch and say, where is the tan positive between 90 and 360? That's a tricky one. Check this. It is between 90 and 360. Sorry. In this quadrant, we're not going to work in this quadrant. So we are left with this one, and that. In this quadrant, tan it's negative. In this quadrant, tan it's positive. See, that's right. In this quadrant, tan is negative. So, but this thing here is positive. So we're going to work in this quadrant, that thing at A. So my 5, it's a y value. It must be -5. My 12 is a negative value. It must be -12. -5 divided by -12, but here, how is it written? Positive. It is because that one is minus, that one is negative. Negative and negative is positive. Be careful when you're doing this sketch, because the next answers will be incorrect if you don't do that. So for me, first I must get the r value. R squared will be equals to the x squared plus y squared. My x squared is -12. My y squared is -5 squared, which gives me 144 plus 25, and that will give me 169. Therefore, my r will be equals to 13. Square root of 169 is 13. Now, then I can then get this cosec. I cannot get the cosec if I don't know what is the other value there. So the cosec I know is the same as sine turned over. So if I know sine, my sine of this angle is opposite over hypotenuse. So it's -5/13. So which means my cosec will be 13 over negative 5. But it must be squared. So I'll have 169 over 25. Okay, so I know sine is going to be this one over that, but cosec will be 13 over that. It's just the opposite of the arrow. Let's look at the sec. The sec of A, so sec is an opposite of cos. So our cos is 12, negative 12 over 13. So sec will be 13 over negative 12. Right, and then the sine, we know already the sine is 5 over 13, which is a negative also, negative 5 over 13. So here you can use a calculator, but do not put decimals, please. So if I use my calculator there, minus 13 over 12, negative into negative 5 over 13, and my answer there will be negative 109 all over 156. So if I go to my calculator, I just press fraction button, negative 13 over 12, minus open bracket, negative fraction button, negative 5 over 13. Then my answer will be negative 109 over 156. Okay. Now the reduction formula. So you see, with the reduction formula, remember with the reduction formula we are going to use this diagram, which is very helpful when you're doing this. So in an exam, writing an exam, you see a reduction formula there, just put this diagram next to it so that then you are able to refer to it. Simplify the following without using a calculator. You see the specifying trigonometry mostly without using a calculator. Where they say, where you have to use a calculator, they won't see anything. They just say simplify. Then you know you can use a calculator, okay? Right, let's check the first one. And these questions I love them most because now the marks are allocated a pay ratio, which is good, you know? They're not allocated per step, but pay ratio. I love it. Cos 180 degrees plus theta. So where do I go? Cos 180, so I'm going to do this plus, that's minus, that's minus. Okay, that's a plus. Right. So this is my cast as we know it. Okay, so now I'm going to say the cos of 180 degrees plus theta. So I'll go to 180 plus, it's in the third quadrant. The third quadrant cos is negative, so I'm going to just write negative cos of theta. 180 is gone. Okay. The next one is tan 360 minus. In the tan 63 minus, tan is negative, so I'm just going to write brackets. Please put a bracket, tan of theta. Once I see a square, the cos square, I just immediately write it as the cos square of theta. Because the sign will not change. Even if it's a negative, the sign will not change. Okay, it is always going to be a positive. This is equals to all over sine 180 degrees minus, it's in the second quadrant, sine is positive, no stress with this one, sine of theta, plus cos squared of theta. All right, so with this, you have 1 mark, 2, 3 marks already, 4 marks. On this step, you already have 4 marks if you know how to do it. Then from there, I'm going to say a negative times a negative is a positive, so I no longer have a negative. This tangent is sine theta over cos theta. Cos squared theta remains plus cos squared theta. Remember, you still have sine of theta. So the cos of theta and the cos of theta will cancel out. Because this sign is on top there, it will cancel with the one at the bottom. What is left now? It is 1 times cos squared theta divided by 1. So which gives me cos squared theta. plus cos squared theta. And the cos squared theta plus cos squared theta gives me two of them. Please, it gives us two of them. We have two of them. Then that will be the final solution. Okay. Right. I'm going to give you 2 minutes to try the second one. 2 minutes to try the second one. Okay, welcome back, and I hope you tried this one and you find it very easy. Remember, I said with a square, then you remember the pi there is 180 degrees, so it doesn't matter what we have. But as long as it's cos squared, then it will always remain cos squared of x. The tan of x, I'm going to change it now to sine of x divided by the cos of x. But because of it's squared, it must also be squared there. Then I'm dividing this by sine of 180 plus, third quadrant, because the sign is negative, right? The cosec 180 minus, remember sine and cosec are both positive there, so which means that cosec will change to 1 over sine of x. Right. Now you can see the sine and the sine here will cancel out. The cos squared and the cos squared will cancel out. Now the answer that is left there is a negative because we have the negative sine squared of x, and that's our final answer. That one was quite easy. So we mark there, we mark this one, and this one will mark that one. We'll mark this one, and then we'll mark that one. Okay. Then we mark the final answer. These questions are quite easy. This is free marks. This is free marks, guys. Once you know this diagram, these are free marks. Then you must know how to do them. Okay. The last question on the reduction formula. It's basically the same thing that we were doing on the other one. Remember, this is 180 degrees. This will be 360 because it will be 180 times 2. This is 180 degrees. This is 360 degrees. That's 360 degrees. So already, you know. Okay, you have your sketch there, down there, sorry. You have your sketch down there, here. The 180 plus, 180 minus, 360 minus, 360 plus. See, I've even indicated them in those quadrants so that then you see. Okay, so here we're going to have equals to 180 minus, it's in the second quadrant, sine is positive in the second quadrant. Put them in brackets, please. The cosec, it's negative in the fourth quadrant. So in the fourth quadrant, it's negative cosec x. The tangent in 180 plus, it's positive in this quadrant. So I just write this positive tangent. Then the sec, it's 360 degrees minus. So 360 minus sec, remember cos and sec are positive there, so it will be sec of x. 360 minus in the fourth quadrant, cos is positive, so I'll have cos is positive. Remember, this is 1 mark, 1 mark, 1 mark, 1 mark, 1 mark. So already you have got 5 marks from in this step only. So then we have sine of x multiply by, so our answer is going to be negative, so I can put it there because I already know negative times positive times positive times positive, negative. The sec is going to be 1 over sine of x. The tangent is going to be sine of x over the cos of x, all divided by, this is going to be 1 over cos of x. The cos will remain cos. I love it when everything cancels out. The sine cancels with the sine, super for me. The cos and the cos cancels out. I'm left with negative sine x all over cos of x, all divided by 1. Then I know that this one I can change it to tan of x because I know. Okay, so the question sometimes the question they say simplify this to one trigonometric ratio. So if they didn't say it, you can leave it here, you still get full marks. Leave it there, then still get full marks also. Okay. So the reduction formula questions, the marks ranges from 5 to sometimes 7 or 8 marks. So please go and practice that, and then from there you get your full marks on these questions. They are not very difficult. Okay, so you cancelled out correctly there, so I'll have it. Okay, right. Let's now look at the identities. So with identities, that's why you need to prove that the left-hand side equals the right-hand side. And mostly we see learners writing a lot of stuff and they say left-hand side equals the right-hand side. Remember, we don't check your final answer. We don't mark your final answer. We check it if it's the same as the right-hand side or vice versa. So here I've also indicated there some of the identities that we have. The famous one, we call it the famous one. You know, sin squared theta plus cos squared theta is 1. So now, how do we work this one out? First of all, I look at the complicated side. You know, one of the complicated side here would be, you see here we only have one ratio, but there we have a lot of ratios. So I just check this left-hand side. Please do not prove, you cannot prove by working on both sides. So work with one side until you get something that is similar or equals to the right-hand side. Or if it's not, but it's simplified, check the right-hand side and simplify the right-hand side. But in this case, let's check. So I'm going to have cos of theta over 1 minus sine theta. There's nothing I can do to that. Minus, then I can change this one to sine theta over cos. Right, so I can have my LCM here, which is cos theta into 1 minus sine theta. So then I'm going to have cos theta, the whole thing, 1 minus sine theta into this whole thing there, it goes cos theta. So in other words, cos theta times cos theta, it's cos squared theta minus. Cos theta there goes 1 minus sine theta. So I'll have 1 minus sine theta. So if I multiply this together, I'm going to have cos squared theta minus sine theta plus sine squared theta, because negative sine theta, this is sine theta, sorry. Negative sine theta multiplied by negative sine theta gives us positive sine squared theta, all divided by cos theta into 1 minus sine squared. Please don't multiply out the bottom one. You can multiply it at the end when you're giving us the answers. So from here, I'm just going to write it here. Sorry about this. So cos squared theta plus sine squared theta, you can see sine squared theta plus cos squared theta gives me 1. So on top, I'm left with 1 minus sine theta. At the bottom, I'm left with cos theta, open bracket 1 minus sine theta. Then I can see this whole thing and that whole thing cancels out. So I'm left with 1 over cos theta. And I know that this one will be the same as the sec of theta. So the right hand side is sec of theta. So I've proved it now. So I can just say equals to the right hand side. Okay. So, or I can just leave it here and then come here and change this one to be 1 over cos theta. And that will be the left hand side and the right hand side are equal. So this needs practice also. You practice, but then you need to understand the tangent and the sec. I've changed them. So I did not change the cos, I did not change the sine. The sine and the cos are in simplified, those are simplified ratio. I must not change them. I can't change them to anything. You can change them to 1 over sec or 1 over cosec, but then you'll be complicating your sum. Right. Okay. The next identity here, you see this one, the left hand side and the right hand side are a bit complicated. Both sides are a bit complicated here. So, but I see, let me try the left hand side. Let me try the left hand side. So I'll say the left hand side, okay, it's equals to, what is the cot of x? It will be cos of x divided by sine of x. What is the tangent of x? So it will be sine of x over the cos of x. So from here, I can take my LCM, which is sine x, cos x. Then sine x, cos x, so it's cos squared of x plus. So now, the cos of x into cos x and x will be sine x, which is sine squared x. Then I know that that top part will give me 1 over sine x cos x. Now I want to show you the trick. That I can do this trick, or I can use the right hand side. I can either do the right hand side, or I can show you this trick. If I do the right hand side, cosec of x is 1 over sine x. Sec of x is 1 over cos x. Multiply these two, you get 1 times 1 is 1 over sine x times cos x. So you can see this is the same as the left hand side. Or I can do it as, break it down as 1 over sine x times 1 over cos x. And 1 over sine x is cosec. 1 over cos x is sec. And it will be the same as the left hand side, the right hand side. You see? Okay. So it's either I can do it this way, check these two, or I can check this one and that one. So identities played, you can play around with them. They are quite nice to work with. I love them because you know you can do, as long as you're doing something legal, you will be able to can get to the left hand side being equal to the right hand side. So you have to do legal things there. Okay, the last identity The sine of x, nothing to do with it. Check the left hand side. So the sine of x, there's nothing I can do with it. But the cosec squared of 180 minus x. Remember I said this, you leave it as it is. But cosec can be changed to what? 1 over sine, but it is squared. Okay, as long as there's a squared there, you won't have a negative because everything will be positive. This is plus 1 over sine x. So one of these cancels out with one of those. Love it. So I'm left with 1 over sine x plus 1 over sine x. Oh, this is quite easy. One of these times one of these would give me 2 of them. So it will be 2 over sine x, which is the same as the right hand side. So what do I do? What do I do? I just add my numerators because my denominators will be the same. Okay. Right. That one was quite an easy identity to work with. Okay. Before we go to the trig equations, we'll take a minute. Okay, welcome back. We're going to now look at the trig ratios, trig equations. You see now, 3 things that we have done now. We have done the Pythagoras type question, that's the first question that we have done. The second part of the question was the reduction formula. Remember, you're also going to have calculator work. Okay, I think that will be the first question. And we have got the reduction formula. We have done the identities. Now we do the trig equation. So trigonometry is divided into those parts. Also, we do have trig graphs. We have also the 2D, 3D. So if you can just make a mind map of the trig and write down all those things and practice per subsection, the subtopic there, you'll be able to can get things right. Now, type 1 of trig equations, you'll have where we have a ratio and a value. That is the ones that we like most, which are easy. You just go to your calculator, press shift and the ratio and get the value, the angle. The other ones, we have a ratio and a ratio on both sides. You see, we have a ratio and a ratio on both sides. We'll look at that. The domain, it's what it is written some there. You'll find that the domain is an element of that, 0 to 360. But sometimes you must first check what is given, because then you give us answers that we don't need. The reference angle, I prefer, this is what I prefer, the reference angle to always be a positive angle, because it's quite easy to work with positive angles in my cast diagram. Okay, right. Let's look at that first question. The first question says tan x equals 1 plus root 3. If that question also has, that question has a ratio on one side and a value on the other side. So 1 plus root 3 is a value. So what do I need to do here? I just go to my calculator and press shift tan, then I'll get the angle. Shift tan of 1 plus, put 1 plus root 3 in the brackets, then the angle that we're going to get there will be x equals to 69.9 degrees. Just approximately that number. Just round it off to 1 decimal. Now, remember that we are saying this value here, if you check this value, it's positive. So if my value is positive, in other words, if my A value is greater than 0, then my solution will be, so remember my interval is from 0 to 360. So my solution will be in the first quadrant or in the third quadrant, because the value is positive. Remember, tan is positive in those quadrants. So this is how I prefer writing it. I'll then draw a table and say, tan is positive in the first quadrant, tan is positive in the third quadrant. In the first quadrant, I don't use any reduction formula. But in the third quadrant, I use 180 degrees plus. Then I'll say in the first quadrant, my solution will be S it is 69.9 degrees. That's my solution. In the third quadrant, my solution will be 180 degrees plus 69.9 degrees. So, which gives me 249.9 degrees, and that's my solution. So, if I look at these two values here, my answers are between 0 and 360. There's no value which is below 0 and a value which is above 0, because my solution is in those quadrants. Okay. Right. And these are easy marks that we must get in the exam. Okay. Let's look at where we have a ratio on both sides. You see, we have a sine on one side, on the left hand side, a cosec on the right hand side. Now, what do? We first work out my right hand side. So it will be 1 minus cosec, but I know cosec it's the same as 1 over sine. So I use my calculator. See, we say solve for x. We didn't say without using a calculator. So you have to use a calculator. So if I say 1 minus 1 over sine of 65 on my calculator, and I get negative 0,103 and other numbers. Okay? So this is the sine of x. So my x value will be, so I don't use a negative when I press shift sign. So I use a positive 0,103 in all those numbers, and the angle that I got was 5,9 degrees. Okay, so 5,9 degrees in this case will be my reference angle. So, but I check here, my sign is negative. Remember, my value, if it's less than 0, is negative. The sign is negative in the third quadrant and in the fourth quadrant. So, as I say, I prefer drawing a table and saying, in the third quadrant, I use 180 plus. In the fourth quadrant, I use 360 minus. And that's easy for me to say my x value will be equals to 180 plus 5,9 degrees. But now I have a problem. My solution must be between 90 and 270. So, which means that my solution will be between 90 and 270. So my solution cannot be here, cannot be there. So my solution will be there and there. But here it cannot be. Why? It is because the sign is positive in this quadrant. So meaning that my only answer will be 180 plus 5.9. So which is going to be 185.9 degrees. That's my only solution. So I do not have a solution there. So can you see the interval that has been given also. Because if I say 360 minus 5 and I get the angle there, it will not be part of it. Obviously, what am I going to get just for interest sake? I'm going to get x is equals to 354.1. And 354.1, it's not part of my solution. So no ways I'm going to have my solution. So you must check your intervals. Okay. Right. Type 3, if I've got an angle here, so can you see we have x plus, now see again here, what do we have? The interval is 0 to 90 degrees. So which means my x plus 30 degrees, it's equals to, I go shift cos 0.74, and I think I got 42.3 degrees there. So what do I do with those degrees there? Then I know it's in the first quadrant, so I don't have a problem. In the first quadrant, I know again it's positive in the fourth quadrant, but we need 360 degrees minus, which is not going to work for me in this case. So it's not going to work for me. So only in the first quadrant I can get x plus 30 equals to 42.3 degrees. X will be equals to 12.3 degrees if I subtract the 30 there from 42.3. Okay. If I check my 12 degrees will be within these two. So it will be within between 0 degrees and 90 degrees. Yeah, about it. Okay. All right. So the trig equations is also part of it. Go and practice. This question ranges from 3 marks to 5 marks. So please let's make sure that we get those questions. Okay. All right. Now the next work here is the trig functions. So the trig functions, these are the trig functions that we do. So you must learn these trig functions, and you must remember our graphs are only between 0 and 360 degrees. So you must learn this function. You must learn how to draw each and every one of those functions. It's very important that you know how to draw. The marks there ranges from about 5 marks to 7 marks. So if you know how to draw these functions, we are already there. So can you see in trigonometry, we can get our minimum mark there should be 30 marks. Minimum. No one should get any mark below 30. Let's get to this function that is given there. F it's sine x, g it's cos x plus 45. So it's inside the bracket there. Where are we drawing our graph? From 0 to 270. So meaning that I cannot draw the graph to 360, it's only up to 270. What is the period of f? So the period of f, this is what we see. We see a 1 there, but period is not 1. What do? If the period is 1 there, so remember the period of that graph, it is going to be 360 degrees. I prefer writing it like this, because that number there, if it was a 2, I'll say 360 divided by 2. If it's 3, I'll say 360 divided by 3. In this case, I've divided by 1, so my period is 360. That's a 1 mark. What is the amplitude of the graph of G? Amplitude is that number that sits there. So that number that sits there is 1. So my amplitude is going to be equals to 1. Okay. So these 2 marks are easy, straightforward, easy marks that we must get. Now, sketching these graphs. Use a calculator. Please use a calculator. This is given. The values there are given, so there's no problem with it. I can use my calculator. So say for instance, I want to start with the first one will be quite easy. I'll say sine of 0, then it will be 0. Sine of 45 will be 0, 707, I think. So it will be somewhere around there. The sine of 90 is 1. So this will be the same thing there. So we're going to check there. And then at 2 to 5, I think it's also somewhere going to be somewhere there. And then at 270 is going to be at -1. 5 is going to be there. So how am I going to draw this graph? Sorry. How do we draw? How do we draw in this graph now? What we're going to do is we are now going to draw a smooth graph by joining this point. Don't use a ruler. So I'm going to try and join this point, and the beautiful graph, and you stop there. Don't make an arrow. The graph is not continuing. It's up to 270. Done. Okay. Right. So now, how do I then draw the graph of the G graph? Same thing. At 0, you're going to have cos of 45. So in other words, at 0, it will be 45. It will be somewhere there. It will be somewhere there. So therefore, at 45, it will be somewhere there. So therefore, you have it at 90. I think it will be somewhere here. So 707, then you have it, that one will be somewhere there. Then at 180 degrees, it will be around this point next to 1 there. And then at 225, it will be around -1. Then from the 270, it will be somewhere there. So therefore, and then from there, you do the same. Then you have your graph like that. Then you name your graph as G and F. Just to sketch these two graphs, using your calculator, you are going to have up to between 5 and 7 marks. So sketching the graph is one of the most important skills that you need to know, and you must sketch proper graphs. You have your calculator, and then you're just substituting those values there. So you see we have a 45. If those points are not given, use the 45 interval. So 45, 0, 45, 90, 135. If it's 30 there, please use 30 intervals. And you draw your sketch by using your calculator. This is easy, straightforward, 7 marks. Okay, now, so sketching of the graph, everyone must be able to do that. All right. The last part of work is the 2D, 3D. So ready, you are on your 50 marks now for the plus minus 50 marks for the trigonometry. So that's the last question of the plus minus 50 marks that we talked to even. So some tips on how to tackle the 2D, 3D. The sine rule is used. When do I use the sine rule? You see, when you have a known couple, so in terms of when we talk about a couple, in other words, we're saying a side and an angle is a couple. So if I've got a triangle like this, and I have got an angle here, maybe 47 degrees, and I've got that line there at 7 centimeters, this is called a couple. Then, for instance, I've got an angle there, maybe 57 degrees, and I don't have this side here. I don't have this side here, so I can be able to get that side because this angle does not have its partner there. Okay, so I can use the sine rule. So I can say sine this over that equals to sine this over that. So can you see I've got one unknown, so I can calculate it. The cosine rule is used when we have SAS. So if I've got a side, an angle, and a side. So these two sides are given, and that angle is given. That side is not given. I can use the cos rule. The area rule is also operates on a SAS also. But you must read each and every question carefully to see the link in the subsections that follow on. That's very, very important. So let's read the question and read and analyze the diagram and see how best you can utilize the information that has been given. Okay. So in the diagram below, AC is the diameter. So it's very important that we read the information. AC is the diameter. So if I go and there's a circle, if I see a diameter in a circle, I'm looking for the 90 degrees. Already I know that that angle is 90. I'm told that this line and that line are equal. So this is 6, so that one will also be 6. Okay. That's the information there. AC is produced to D such that DC and CD are equals to 6. What is the size of angle ABC? Oh, I've already answered the question. Angle ABC, it's equals to 90 degrees. The reason it's angle subtended by a diameter, or angle in a semicircle. Okay, so those two reasons are acceptable. Right. Okay. The next one says the size of BCD. BCD, they're talking about that angle. But what do I know about this angle in this triangle here? I already see that that angle is an exterior angle of a triangle. So meaning that this triangle here is extended there in that angle. So 90 plus 54 will give me how much? I think that will give me 144. Right. The reason will be exterior angle of a triangle. Okay, it's equals to the sum of two opposite interior angles. So then I know this 144. Already I can get these two angles, but I'm not requested to do that. So now the next one, it's find the length of BD. BD. Isn't it that I know that angle is 144? This side is 6, that side is 6. Remember, it works on the which one works on SAS? It's the cosine rule. So it's BD squared, it's equals to 6 centimeters, 6 squared plus 6 squared minus 2 times 6 cos of 144. That will be the length of this line. So if I work out this one, remember BD squared, so the BD, how am I going to get the BD? So BD squared is going to be 130,25. So BD square root of that will give me 11.4 centimeters. You can see that length there, it's 11.4 centimeters. I already know that. Okay, the length of AC is that line here. But I already know that this line here is 6. That angle is 54. So to get this one, the easier way is to get the sine of 54. Remember, this is 90. So sine of this angle is opposite over hypotenuse. So which will be 6 over AC. So making AC the subject of the formula will give me 7.4 centimeters. So this length here is 7.4 centimeters. Okay, right. The area of this triangle here, I know that this one, sorry. So this one here, I already know that it's 7.4 centimeters. This one is 6, this is 90. If I get this will be the height, that one will be the base. So for me to get a height, I can get AB squared. It's equals to AB squared equals the hypotenuse, 7.4 squared minus 6 squared. So I'll get AB to be equals to 4.3 centimeters. So if this side is 4.3 centimeters, I can then get the area of triangle ABC, which is going to be half of the base is 6. The height of that is 4.3. So remember, the whole will be centimeter squared, its area. So if I multiply out, it will be 3 times that, it will give me 12.99 square centimeters, and which is the area. If I don't want to do that, then I can get the sides, there are so many ways to do it. I can get this angle and use the sine rule, it's also acceptable. Or I can get this side and use the sine rule, it's still acceptable. right? But I know it's a right angle triangle. I can use half base times height. So the base is that, the height is that, so I can use that. Okay, right. So those are the sections that we're going to be doing in trigonometry. Remember, we said Pythagoras type. Number two, we have the reduction formula, identities. We have the trig equations. We have the trig graphs. We have the 2D, 3D. These are the sections. So if you do your mind map, you say, now today I want to practice the trigonometry for 50 marks. You break it down into those subsections and say, now today I want to do Pythagoras type of questions only. I want to do this only, and then from there you do the whole trigonometry to see how many marks you can get on this. Right, and this is by all. I want to take this opportunity to really wish you well in your exams. You're writing paper one next week on Friday, and paper two the following week on a Monday. Please make sure that you work very well and practice, and don't practice like everything at once. Please break down your topics so that then we concentrate and focus on a particular topic. Then before you write a final examination, you take the whole question paper, you test yourself before you go into the final examination, and in that way you can really get the marks that you want. Now go out there and really do your best, and yes, you can. Thank you so much.